In this video, I will explain determine the Fourier series for the half wave rectified cosine function shown below. This is the half wave rectified cosine function x of t minus 1 plus 1 3 5 minus 3 minus 5. Here amplitude of this one is 1. Here plus 2. Here 2. Minus 2. Here 4. This is the half wave rectified. Determine the Fourier series for the half wave rectified cosine function shown in below. First of all, I have to find out the time period of the waveform. So many ways the time period of the waveform is determined. One particular thing is T naught is equal to minus 2, T naught plus small t naught plus capital T naught is equal to 2. This is the one way of defining a time period. Therefore, T naught plus T naught is equal to 2. We know that small t naught is minus 2 plus T naught is equal to 2. T naught is equal to 4. In another way of defining a time period is, this is the starting point here. So 1 is starting point, minus 1 to come to, this is the, only again the waveform is repeated from third. This is the time interval. T naught is equal to minus 1, T naught plus T naught is equal to 3, minus 1 plus T naught is equal to 3. Therefore, T naught is equal to 3 plus 1, that is equal to 4. This is the time period of that given waveform. Now, cosine function is actual cosine function is this is the actual cosine function. This is 1. This is 1 minus 1. The middle 2, 3. This is the 4 minus 1 minus 2 minus 3 minus 4. X of t is equal to general A cos omega t. Here amplitude of that waveform is 1. 1 into cos omega t. 1 into cos omega t, that is equal to cos 2 pi by t into t. Here t is the time period of this waveform. This is the starting point here. This one is 4. T is equal to 4. T is equal to 4. Therefore, cos 2 pi by 4 into t, that is equal to cos pi by 2 t. X of t is equal to pi by 2 t. Here again time period is from 0 to 4. or -1 to 3 or -2 to 2. -2 to 2, whatever it may be. Therefore, x of t is equal to cos pi by 2 t. This is the time period of that waveform is 4. Cosine half wave rectified waveform is 4. Find out coefficients a naught, an, bn is equal to 0 because symmetry. This is the even symmetry. In the positive side, the waveform is nature is like that. In the negative side, the waveform nature is like that. This one is x of t is equal to x of minus t, 0 to 1, 2, 3, 4, 0, -1, -2, -3, -4. Here minus t means minus t, minus of minus, plus 1, plus 2, plus 3, plus 4. Therefore, x of t is x of minus t. Our even symmetry. Even symmetry. For even symmetry, bn is equal to 0. Find out a naught. Find out a naught. Therefore, a naught formula is a naught is equal to 1 by t naught plus small t naught plus capital T naught x of t dt. Here small t naught is minus 2. Small t naught plus capital T naught is 2. -2 to -1, the x of t value is 0. -1 to 1 is cos pi by 2 t. 1 to 2 is again 0. -2 to 2. Here 1 by 2 t naught is 4. Time period of the waveform is 4. -2 to 2 x of t dt. -2 to -1, 0, -1 to 1. X of t is this interval is split into 3 intervals. 1 by 4 minus 2 to -1 x of t dt plus -1 to 1 x of t dt plus 1 to 2 x of t dt. Therefore, the time period is from -2 to +2. That is equal to 1 by 4. This value is 0. This value is 0 because there is no waveform here. -1 plus 1, this one plus 2, -2 -1 0, -1 to 1 is cos pi by 2. These two are zeros. Only -1 to 1 interval is there. That is cos actual waveform cos pi by 2 t dt. That is equal to 1 by 4. Integral of cos pi by 2 is sine pi by 2 t by pi by 2 minus 1, 1. That is equal to 1 by 4, 2 by pi. Substitute t value is 1. Sine pi by 2 minus t value is -1. Sine of minus pi by 2 is minus sine pi by 2, minus into minus plus. That is sine pi by 2. Sine pi by 2 plus sine pi by 2 is 1. Sine pi by 2 is 1. That is equal to 1 by 4 into 2 by pi. Sin pi by 2 is 1. 1 plus 1 is 2. Cancel, therefore 1 by pi. A naught is 1 by pi. A naught value is 1 by pi. Now I will concentrate on an value. An is equal to 2 by t naught, t naught, small t naught plus capital T naught, x of t cos n omega naught t dt. Here t naught, we know that t naught is 4, 2 by 4, small t naught is minus 2, small t naught plus capital T naught is plus 2, x of t cos n omega naught is 2 pi by t naught t dt. That is equal to 1 by 4, minus 2 to minus 1, 0. Therefore, minus 1 to 1 is there. X of t cos n 2 pi t naught value is 4 pi by 2 dt. That is equal to 1 by 4 minus 1 to 1. X of t is cos pi by 2. X of t is cos pi by 2 dt. Cos pi by 2 t cos n pi by 2 t dt. That is equal to 1 by 4 multiply here 2 that is 2 by t naught, that is 2 by 4 here, 2 bring inside, 2 cos a plus b plus cos a minus b is equal to 2 cos a cos b. By using this formula here, 2 cos a cos b is minus 1 to 1, cos a plus b cos pi by 2 t plus n pi by 2 t. This is cos a plus b cos pi by 2 minus n pi by 2 dt. That is equal to 1 by 4 integral minus 1 to 1 cos 1 plus n cos 1 plus n pi by 2 into t plus minus 1 to n cos 1 minus n pi by 2 into t is the common term here, dt here dt. That is equal to 1 by 4 integral of cos 1 plus n pi by 2 t is sine 1 plus n pi by 2 t by 1 plus n pi by 2 1 to minus 1 plus integral of cos 1 minus n pi by 2 t dt is sine 1 minus n pi by 2 t by 1 minus n pi by 2 minus 1 to 1. Here substitute 1 here, 1 and minus 1. T is equal to 1, that is equal to sine 1 plus n pi by 2, 1 plus n pi by 2. Here minus 1, sine of minus theta is minus sine theta, minus into minus plus, because lower limit by using minus sign. Sine 1 plus n pi by 2 by 1 plus n into pi by 2. In the similar fashion, plus sine 1 minus n pi by 2 by 1 minus n pi by 2. Again minus of minus, plus sine 1 minus n. Substitute t value is equal to minus 1. Sine of minus theta is minus sine theta, minus into minus plus by 1 minus n into pi by 2. That is equal to pi by 2 is the common term in all places. Bring out, that is 2 by pi. 2 by pi. Here the sine pi by 2 plus n pi by 2 is sine 90 plus theta is cos theta. That is cos n pi by 2 by 1 plus n, because pi by 2 is bring out, that is 2 by pi. Here also cos n pi by 2 by 1 plus n. Here cos n pi by 2 by 1 minus n plus cos n pi by 2 by 1 minus n. That is 2 by 4 pi. This is 2 cos n pi by 2 by not 2 here. Cos n pi by 2, 1 by 1 plus n, 2 by 1 plus n, cos n pi by 2, 2 by 1 minus n. 2 term is bring out, 2 into 2, 4 by 4 pi, cos n pi by 2 is also common term, 1 by 1 plus n plus 1 by 1 minus n. 4 cancel. Therefore, final one is cos n pi by 2 by pi, 1 plus n into 1 minus n, that is 1 minus n square, 1 minus n, these two are cancelled. Cos n pi by 2, 2 by 1 minus n square by pi. This is the an value. An is cos n pi by 2. An is equal to cos 2 cos n pi by 2, 2 cos n pi by 2 by pi into 1 minus n square, where n is equal to 1 comma 2 comma 3 and so on so forth up to infinity. Let n is equal to 1. Let n is equal to 1. Therefore, a1 is equal to 2 cos n is a cos pi by 2 by pi into 1 minus 1. Cos pi by 2 is 0. 2 into 0 by pi into 0. 0 by 0. Therefore, a1 is undefined. A1 is undefined. Therefore, we use L'Hospital rule. An is equal to 2 by pi d by dn cos n pi by 2 by d by dn 1 minus n square. That is equal to 2 by pi. Differentiation of cos n pi by 2 is minus sine n pi by 2. Differentiation of n pi by 2 is pi by 2. Differentiation of 1 minus n square is minus 2n. This is 2 cancel. Pi cancel. Minus minus cancel. Therefore, an is equal to sine n pi by 2 by 2n. Now substitute n is equal to 1 value. Sine pi by 2 by 2 into 1. Sine pi by 2 is 1. That is 1 by 2. A1 value is 1 by 2. A1 value is 1 by 2. For 3, 5, 7, for odd values, 3, 5, 7, that is A3 is equal to 2 by pi 1 minus n square cos, let n is equal to 3, cos 3 pi by 2, cos 3 pi by 2. Cos 3 pi by 2 is 270, 3 pi by 2 is 270, cos 180 plus 90, cos 180 plus 90, that is cos 90 minus cos 90, that is 0. 2 by pi into 1 minus 3 square cos minus cos 90. Cos 90 is 0. 0 into 2 0 by pi into minus 3 square 9. 1 minus 9 is minus 8. That is 0. For odd values except 1, for n is equal to 3, 5, 7 and so on up to infinity, the an value is 0. Now let us see even values. For n is equal to 2, 4, 6, 8, it has some value. Therefore, an is equal to 2 by pi cos n pi by 2 by 1 minus n square. That is equal to 2 by pi minus 1 cos n pi by 2 is minus 1 whole power n by 2 by 1 minus n square. 2 is equal to substitute n is equal to 2. It has some value. N is equal to, it has some value, like that. For even values, n is even. N is even. Therefore, an is equal to, n is even. An is equal to 2 by pi minus 1 whole power n by 2, 1 minus n square. Now write down the Fourier expansion formula. X naught is equal to a naught plus sigma n is equal to 1 to infinity an cos n omega naught t. Bn is 0. No need to write here. That is equal to A naught, n is equal to 1, substitute n is equal to 1, A1 cos omega naught t plus n is equal to even values. For odd values, that an is 0, 2, 4, 6, and so on, so forth up to infinity here. An value is 2 by pi minus 1 whole power n by 2, 1 minus n square cos n omega naught. That is equal to a naught, a1 cos omega naught t is 2 pi by t naught t. Here 2 by pi into 1 minus n square. Sigma n is equal to 2, 4 up to infinity minus 1 whole power n by 2 cos n 2 pi cos n 2 pi by t naught into t. That is equal t naught is 4. A naught is already derived. A naught is 1 by pi. A1 is 1 by 2 cos 2 pi pi. T naught is 4 into t. It's 2 by pi into 1 minus n square. N is equal to 2, 4, and so on. Infinity cos n 2 pi by 4 into t. That is equal to 1 by pi 1 by 2 cos pi by 2t plus 2 by pi into 1 minus n square. Here minus 1 whole power n by 2. Sigma n is equal to 2, 4, infinity, and so on. Minus 1 whole power n by 2 cos 2 n pi by 4. That is pi by 2 t. Here n is equal to 2k. That means for n is equal to 2, k is equal to 1. N is equal to 4, k is equal to 2, like that. Substitute finally 1 by pi 1 by 2 cos pi by 2t plus 2 by pi into 1 minus n square. Instead of n is equal to 4, k is equal to 1 to infinity minus 1. Here n is 2k by 2 cos. Here n value is here cos n is equal to 2k pi by 2 into 2. 2 to cancel. Finally, x of t value is x of t is equal to 1 by pi 1 by 2 cos pi by 2t plus 2 by pi into 1 minus n square. Sigma k is equal to 1 to infinity minus 1 whole power k by here n is 1 minus n is 2k, that is 4k square. 1 minus 4k square cos k pi into t. This is the complete Fourier series expansion of the half wave rectified cosine function. With this, total is completed.